everyone. Welcome back to another edition of the engineering side of data. We're going to be talking about ETL and ELT today. I've got Dan Silberman with me. Dan, please introduce yourself.
Hey everyone, I'm Dan Silberman. I'm co-founder, CTO of a company called Mozart Data. I've been a software engineer for about 15 years now, working across a bunch of different industries, finance and gaming, a bit of crypto and healthcare. Generally, as a data engineer or application engineer, working alongside data analysts, data scientists. And nowadays, I'm more of an engineering manager who tries to still find time to write code. And my company, Mozart Data, we are an easy-to-use, all-in-one data platform. So we're going to be talking about ETL and ELT. We do ELT and data warehousing. So we make it really easy to sync data from currently over 150 different data sources, no engineering needed. And then we have a robust SQL-based transform layer for building pipelines, data validation, cataloging, observability, monitoring, and a bit of reverse ETL.
Nice. Yeah, appreciate the introduction there. And hey, thanks for coming on the show.
My pleasure.
All right. Yeah, so we've got two acronyms here. And I've been saying ETL for a long time. So I guarantee I'm going to mess it up at least 10 times. I'll go with 10. Hopefully it's less, but
Same.
Realistically, it's 10. And yeah, just in time for the holidays too, right? So if this comes up at the Christmas dinner, everybody will be well armed to take on the uncle, so whatever position they have.
Exactly.
All right. Let's get into the questions here. I usually start these off with a fairly broad one, but what is ELT?
So ELT stands for extract, load, transform, as opposed to ETL, which is extract, transform, load. So just kind of changing the order of some of the systems. I would say let's back up a second and talk about the problem both of these are trying to solve. And I would say that's to make data usable and actionable throughout your organization. So typically or originally, this was done primarily by data engineers, pulling data out of different systems, whether that's databases or different SaaS tools, organizing them in a data warehouse, and then allowing non-engineers, whether that's data analysts or data scientists, or just other technical users, to build dashboards, answer questions about their data. So I think one way you can think of it is, imagine we're drawing up this system on a whiteboard from, the start of the system on the left to the goal state on the right. On the goal state on the far right, you might have dashboards and spreadsheets and BI tools that less technical users are using to take action and ask questions about your data. Then on the far left, you've got the sources of data where your data starts. So that's databases that your application is using, and a bunch of SaaS tools that your company is using to run the business. And so then what we're really talking about when we're talking about ETL is the middle part of that. How do we get the data from other tools into a usable state for, our customers as engineers? Our customers in this case are data analysts or operations folks. So these systems generally started as ETL, so pull data out, transform it into the shape that will be more useful to people on the right hand of the whiteboard, and then load it into the database, hook up BI tools onto that database, and then they can do whatever they need to do. So in that paradigm, the engineer is basically doing everything. They're pulling data out, they're transforming it, they're combining it with other data sources. They need to understand the use cases that the people on the right side are going to be using it. They'll handle, ideally they'll handle things like monitoring, observability, validating and testing the data, and then load it into the database, and then others can do whatever they want with it. So ELT, which is I think what we're mostly talking about now, turns that on its head a little bit and says, actually, the engineers are just going to pull it out and then put it into the database and not worry too much about how is it shaped, what is it going to be used for. Let other people who are actually going to be asking and answering those questions deal with the transforming and preparing it and putting it into a better state. So that's maybe a long-winded answer to say a little bit of the history of ELT versus ETL.
Yeah, perfect. I know I have some suspicions as to why ELT is so popular nowadays. Why do you think it's so popular?
I think the biggest reason is because it's a better separation of concerns for the people that are better suited to perform each of the steps. So, there's an E, so there's the extracting that basically has to be done by engineers. There's an L, the loading, that basically has to be done by engineers. So if you do ETL and you bookend two things that have to be done by engineers, it's going to be hard for other people to do the transforming in the middle. But if you rearrange things and say, no, the engineers are going to do the E and the L, and then they're going to hand it off, and the interface between them and the people doing the transforming is, relatively unorganized tables in a data warehouse, it's much easier for the people that are better suited to do the transforming to take it over there and have one team or one person do EL, and then a different team or different group of people do the T. I think, have you heard of Conways Law?
Actually, I have, yeah. Please explain it, though.
So I Googled it right before this call so I could get it right. So this was Melvin E. Conway, 1967, computer scientist. He says, any organization that designs a system, defined broadly, will produce a design whose structure is a copy of the organization's communication structure. And I honestly, I heard this 5 years ago or so, and then I looked at the company that I was at the time and some of my previous companies, and it's remarkably true. I would urge your listeners to think of their company and the system design, and then compare that to the org chart of their company. For example, I worked at one company. I won't take too long on this, but worked in one company where the engineering team was divided. There's the front end team, the application back end team, and the data engineering team. And that was the org structure, decided before I got there. But you could see the system design. Each of those teams had their own Git repo. Each of those teams had their own web servers. And so you could see how over time our systems had evolved to match the org chart. And then we reorged into product teams that would have, each product team would have some front-end engineers, some web application back-end engineers, and some data engineers. And over the next 2 years, the system evolved to match that change in org chart, and people were spinning up new repos and new services to better match. And that happens, I think, primarily because you don't want to be blocked having to gain consensus with other teams to make changes. So it's just kind of easier to start separating your concerns. In smaller teams, you might see smaller teams tend to have one repo, one GitHub repo, one monolith system. And then as you grow and you separate into more teams, that's when you start having more things like more repos, more microservices. So to bring it back to ETL versus ELT, if your organization is going to be such that engineers will be moving data around, and then other groups of people will be using that data, it makes more sense if you separate your systems to better enable that. And so ELT better enables that because the engineers can be focused on the E and the L, and then the other teams can be focused on the T, and it's just harder if it's ETL with the T part being in the middle of what wants to be a separate team.
And those people that are responsible for the T, they're often, you kind of touched on this from the organizational perspective, but they're often much closer to the data. They could be the ones asking a lot of the questions, and then therefore they should know exactly what the format or the transformations necessary to get it to answer those questions.
Yeah, exactly. I think SQL itself as a language has become a lot more popular, particularly amongst non-engineers. So a lot of our customers definitely would not call themselves data engineers. Many wouldn't call themselves data analysts. There's sort of this, I would say, growing class of people who have picked up SQL along the way to be able to do their jobs better with titles, operations, marketing ops, sales ops, revenue ops, growth, product. Definitely would not consider themselves engineers, but now know SQL, have picked up SQL, And so they're comfortable in a BI tool. And now that the tools are more SQL based, they can do the transforming themselves. Because a BI query is often, that's where a transform starts, and then you want to move it into the transform layer to help other people take advantage of the table or the filtering or the reorganizing of data that you've done in a BI tool. So if those people can take advantage of that sort of tooling, then you've freed up the data engineers, and like you're saying, you've kind of brought that power to the people who are closer to the business questions and the business needs.
Yeah, absolutely. Do you think that you're talking about analysts or analytic engineers, so some of them are really good about writing SQL for reporting or dashboards or analytics, we'll call that. But what kind of things do they need to do when they start writing transformations in SQL? Is it significantly different? Is it pretty much the same?
It's pretty similar. I mean, a SQL query that you're writing in a BI tool like Mode, what they're giving you, the output of that is, rows and columns, and then maybe you put a dashboard on top of that. So if you're writing code and you're saying, hey, I need to pull data, I need to join these 3 different sources, I need to pull some user data from these 2 different tables, and then I need to pull some data from, maybe we have our Stripe data ingested. So we want to marry product data, who's using the tool, what are they doing, and then revenue data. So you can see maybe what are they doing right before they buy. If you do all that in a BI tool, you're writing a big SQL query so that you can get this robust table. That's what you want as a transform. You want to move that SQL into the transform layer so that table is just regularly produced, and then other people can take advantage of it rather than it just existing in your one dashboard.
Gotcha. That makes sense. One of the things that occurs to me is, when I ask that question about why has ELT become so popular, I think a large portion of it is due to the tool set, right? So we're talking about cloud data warehouses, ingestion tools, certain things like Mozart as well, transformational tools. Yeah. Can you talk a little bit about that? What do you think is, why did cloud data warehouse or, MPP data warehouses, how have they contributed to the popularity of ELT?
Yeah, that's a really good point. So if I understand what you're saying, I mean, if you're doing ETL, if the engineer is doing the whole thing, the T is happening in some web server, you're extracting data out of some API or some database, then in memory, you're transforming it, and then you're loading it into the database. The cloud databases, cloud data warehouses in particular, columnars, have gotten really powerful and relatively cheap over the last 5-ish years, to where moving more of that work off of servers and into these databases is easier and now cheaper. Storage is ridiculously cheap in these things, and compute is relatively cheap. And I think that's the big driver of just move more work into the data warehouse. You also have advantages, like once it's there, it's easier to kind of put standardized monitoring on top of the data warehouse rather than, arbitrary Python or Java that's running in a server.
Security as well, I imagine. And I think you mentioned it, the elasticity, right? The ability to scale up and scale down. So you can scale up for those transformational workloads.
Yeah. I'm most familiar. We use Snowflake at Mozart Data, so I'm most familiar with that. But they have one of their big innovations was separating compute and storage. So you can pay nothing for storage or for compute when you're not actually computing something. And then you spin it up, do your computation, spin it down. You're not paying when it's spun down, and you can spin it up really high if you need to. And it's going to do parallel processing on your data. Yeah,
that storage is definitely one of the other key factors of the cloud data warehouse, right? The fact that it's so cheap that you can afford to. Yeah, ridiculous, right?
Yeah.
Yeah, you can bring over all that raw data, and it's not going to break the bank.
Mm-hmm.
What about ingestion tools? That also seems like a very important aspect or key factor in why ELT is gain some momentum, right? What's going on? Why are those important? Why are they such a big impact thing?
Honestly, I don't know if these came sort of before the switch to ELT or if they're kind of more of a natural driver. So I would say these tools are basically, I'm talking about tools like Fivetran, Stitch, Airbyte. These are basically EL tools. So they sort of require that you're moving the T elsewhere. They don't know anything about your business. They don't know anything about what your C-suite is asking. They don't know anything about your problem. So they just focus on EL, which means they can basically, they'll pull data out of, we work with Fivetran. I know they have something like 140 connectors. And they will take data out of, Salesforce databases, Shopify, Google Ads, Facebook Ads. Those are some of our most popular ones. And then they'll put them into the database in a reasonable format. But like I'm saying, they don't know exactly what you need to do with them. They're certainly not going to merge them with your other data sources. But that, I don't want to say it's become commoditized, because the ability to do that well and reliably is super important. But they can take the EL and do that in a generic way that's going to be generally useful for everybody. And then different companies can take what they've landed in your data warehouse and transform it into the specific needs of their business and, merge it with their other data sources, things like that.
Yeah, that makes sense. What do ETL proponents, right, fans of ETL, the old school way of doing it, what do they get wrong about ELT?
That's an interesting question. I think they say it's more expensive. So kind of like we were talking about before, I would say now that storage and compute on the warehouses is relatively cheap, that it's no longer more expensive. And particularly if you're including data engineer salaries, then ELT, I think, is definitely less expensive. Not that they're not as skilled, but data engineers, very expensive. And the more that you can kind of put the transforming into the hands of operations folks, you're probably saving money on salaries as well. Another one I've heard is that ELT is less secure. You're putting everything into the data warehouse. It's this big shared resource. So how is that going to be secure versus transforming things and, filtering out data before it ever gets there? But at least with Snowflake, there's the data warehouses now have very robust data governance at the warehouse level, schema, table, row, column level. You can hash columns. You can give different users different roles that have only access to just the data that they need. So I don't think security is anymore a reasonable critique of ELT.
Is there a place for data engineers in the world of ELT?
Oh, absolutely. I mean, we say, part of what my company is trying to do is do the data engineering for your company so that you can just focus on the specifics of your data and kind of enable, like we're talking about, these like more operationally people to take advantage. But in general, like it's better for data engineers to spend their time building tools, solving problems that are unique to their business and their data. So I would say it's a waste of time for an engineer today to write an API that pulls data out of Salesforce and transform it, or pulls data out of a Postgres database and writes it into Snowflake. That's a solved problem, but there's always going to be problems that are unique to your business. Maybe there's some tool that your company uses that is a little bit more niche, so you can't get it in a tool like Mozart Data or Fivetran. So building those long tail of connectors. Also, I don't really like the term big data. It's pretty relative, but there are cases where you do want to do some filtering of data. If you're talking server logs or event streams, then there could definitely be reason to do some transforming and some filtering before that gets into your warehouse. And that still generally lives more in the data engineering world. One other thing that is becoming more popular is reverse ETL, and that can often be better handled by an in-house data engineer than some external tool.
And that's that's kind of what I would think. I may be using some older terms, or like operational BI, right? That's this idea of, hey, we're going to get information out of our data warehouse that could benefit those tactical decisions. So they're actually pushed back to things like Salesforce or some other CRM or maybe inventory system, things like that. Is that correct?
Yeah, exactly. Very common use case to play off of your Salesforce. Say you're pulling Salesforce data into your warehouse, doing some combination with your product data, seeing what these prospects are doing in your product, and then maybe you have some sort of algorithm that will give them a lead score. So you're saying which of our potential customers are most likely to buy from us. That's all well and good to get that into a BI tool, and you have some report that shows that. But even better if you can push that back into Salesforce, and then your sales team can continue living in the product that they're most comfortable in, but have this added value produced through your entire data system.
Gotcha. What? So why are organizations still developing ETL solutions for these things that they could be doing in ELT?
I mean, I'll continue with, I think my main theme is these are solutions to people problems. Data systems are sticky and hard to replace. So momentum is a big reason. The people that have been maintaining these systems are generally the ones who will continue to maintain these systems. It's just slow to change, who owns which parts. And if engineers are owning, an ETL system, they'll continue to build on top of it, and they'll generally build tools for engineers like themselves. So there's just momentum, I think, behind it. I would say, I think ETLT, we sometimes will call our product ETLT. Basically, extract, do some transforming, load, do more transforming. I think that's a really natural progression path. If you have a very robust ETL system, it's still pretty natural. You're still going to end up with a data warehouse with a bunch of tables. Very easy to add on some transformation tools on top of that and become ETLT. And then maybe over time, you'll eliminate the first T if necessary, or, if it ain't broke, don't fix it.
Gotcha. Is the T on the back end, is that useful? You mentioned just maybe for transitional periods, but maybe for domain specific things, I would imagine as well, right? For this particular department. Okay. Yeah,
exactly. There's also just, there's a lot more innovation happening on the trailing T on data warehouse transformations. So there's just, I think that doing stuff there is becoming easier and more reliable because tools like Mozart data, DBT is a big one, are building on top of that. So you're getting more like, monitoring, observability, data cataloging, that sort of thing is being built on top of the trailing T layer. So there's just more and more advantages to doing it in that paradigm as time goes on.
How do you see ELT improving in the coming years? Like, what's next? What are the advancements that we're going to be seeing?
So some things that we're working on right now, data discovery, kind of like I was just saying, like there's more advantages to building on top of the warehouse. You can see who is using what data. You can see which data is being used more. You can see which data is being used along with other data. So you can start to build tools that help problems like, hey, we just got a new sales operations person. We just got a new marketing person, and they see, a data warehouse with 10,000 tables. How can they understand what's actually important and what's not? And people are building more and more tools on top of that, including us. Similarly, I would say data governance is still basically managed by data engineers. But this is one thing that we're working on to make easier for less technical users to build things like, roles and permissions such that the marketing team only has access to the data that they need and the sales team only has data to the access they need. Currently, in most companies I've seen, that would require data engineering. But I think that's something that's coming soon.
And that's probably just a lack of tools centered around that, right? So traditionally, these data governance tools integrate with pipelines, or they're called with various APIs. But now, that makes sense. That's just another similar to transformation, right? If the people that know the data the best should be doing the transformations, they should also be the ones in charge of being the stewards, the governing of that information.
I also think there'll be more sharing of transforms. So as tools like Fivetran become more and more popular, kind of the initial schema, the initial structure of data that you get from hooking up a various tool. So, let's say you have HubSpot. The initial schema that you get from hooking up HubSpot through Fivetran to your data warehouse is becoming somewhat standardized. So more people can share their transforms on like better ways to improve that schema. And in particularly something that isn't really done right now that I think might happen in the coming years, sharing of transformations that combine data from different sources. So that's something that we're working on where, let's say you pull data out of all of your marketing tools. You've got your Facebook ads and your Instagram ads and your Google ads, et cetera, in your data warehouse in, probably separate schemas. Ultimately, what you probably want is some consolidated table, dim ads, things like that. And as the initial schemas get standardized, so can the pipelines that come from that, and combining of data, cleaning of data, things like that. Oh,
wow, that is very interesting, that concept of, so sharing it across customers, industries, right? Mm-hmm. Okay, fascinating.
And last thing I can think of on this, reverse ETL. We were talking about that before, but that's definitely becoming way more common. We work with a good partner of ours, High Touch. It's a good tool for that. I think more and more people are realizing, we invest all this money in getting a robust data pipeline. How do we take even more advantage of it? Let's get the data, back into our systems, and kind of creating, instead of, as I was describing at the very beginning, you've got like a whiteboard from left to right. And with reverse ETL, you actually have more of a circle. Data goes in a loop. You can get feedback loops going, and that can be really powerful.
Nice. And I imagine the fact that in an ELT scenario, you have all that raw data in your data warehouse, so you can provide that that finer grain of information in addition to aggregated data for that reverse ETL for those operational aspects.
Absolutely.
Excellent. Well, hey, Dan, I appreciate you coming on and spending some time talking about ELT and ETL.
My pleasure. Thanks for having me.
Thanks. Appreciate it. And for everybody, make sure you like and subscribe on YouTube and your favorite podcast app. Until next time.